studying supermassive black holes. We're talking about the monsters at the center of galaxies, including our own Milky Way's Sagittarius AI. It's going to track how they gobble up stars, how they spit out energy, and maybe, just maybe, it'll help us answer the biggest question of all. What's inside? This brings us to the juicy stuff, time travel. We've all seen it in movies like Interstellar. A brave astronaut dives into a black hole and ends up in another dimension or another time. Is any of that real? Well, theoretically, maybe. According to Einstein's theory of relativity, the immense gravity of a black hole warps space-time so dramatically that time itself behaves differently. Imagine a planet orbiting a supermassive black hole, like the fictional Miller's planet in Interstellar. For every hour that passes for the astronauts on that planet, 7 years go by back on Earth. That's not science fiction. That's a real calculated effect of gravity called time dilation. You wouldn't be traveling backwards in time, but you'd essentially be jumping into the future. You could orbit a black hole for what feels like a few years, return to Earth and find that centuries have passed. Everyone you ever knew would be long gone. Talk about a one-way ticket to the future. But what about going through a black hole? Well, the standard model says you'd get stretched into a noodle, a process grimly named spaghettification. Fun, right? But some wilder theories propose a loophole. They suggest that if a black hole is spinning fast enough, it might create a stable path through its center, a wormhole, that could, in theory, connect to another point in space, or even another universe. And this is where things get even more bizarre. For every action, there's an equal and opposite reaction, right? So, if a black hole is a cosmic vacuum cleaner that sucks everything in and lets nothing escape, could there be an opposite? Enter the white hole. A white hole is the theoretical twin of a black hole. It's a region of space-time you can't enter from the outside, but from which matter and light can escape. Think of it as a cosmic fountain, constantly spewing out energy and matter. While black holes have a point of no return called the event horizon that you can only cross going in, white holes have one you can only cross going out. We've never actually seen a white hole, but the math that predicts black holes also allows for their existence. Some physicists even speculate that black holes and white holes could be two ends of the same tunnel. Information goes in the black hole and poof, it comes out the white hole somewhere else in the universe, or maybe even in a different universe entirely. Could the Big Bang itself have been the result of a white hole erupting? We don't have the answers yet. But with instruments like the James Webb Telescope pushing the boundaries of what we can see, we're getting closer every day. The universe is a strange and wonderful place, and black holes are proof that the truth is often far weirder and way more exciting than any fiction we could ever imagine. Keep looking up.